Good morning. Today our lesson is talking about radian measure. There are two units there are two common units to measure an angle: degrees, as we know before, and radian. Degrees, like when I say 180 degree. Radian, like when I say pi. This is a radian, and this is another way to measure a degree to measure an angle in degrees. Now, here we have a circle. We have the circle now. Now, each circle, it has a center. Now, and also we know that the angle, if I want to draw any angle, I need an initial side, I need a terminal side, and a vertex. So these two sides are intercepted in one point, which we call it vertex. Because of that, we will name this two sides with the vertex with an angle. Now, but if the angle has its vertices, if this angle, okay, has its vertices on the center, we called it now an central angle. So a central angle, it's the same as an angle, but its vertex is in the center of the circle. So as you see from here, a central angle of a vertex is an angle with a vertex at the center of the circle. Okay. Now, what about the intercepted arc? An intercepted arc, as you see from here, these two angles, its sides has an endpoints. Now, an arc or the curve that connects between these 2 points on the central angle, we called it intercepted arc. Now, if I want now to measure this central angle, I will use the radian. So the radian is a way to measure a central angle. And it's like a degrees. It needs an initial side and it also needs an terminal side to measure it. Now today, I will discuss with you how can I convert from degrees to radian and from radian to degrees. Now, to convert from radian to degrees. Okay, I want now to convert from radian to degrees. I have an angle in radian. Okay, I have an angle in radian. So I need the answer in degrees. So I multiply by 180 in degrees over by in radian. So after that, radian cancel by. So my answer will be in 108 and it will be in degrees. Example. If you have 3 pi over 2, this is a radian. I want to convert it to a degrees. So I multiply by 180 over pi. Then by cancel by. This is simplifying. 2 over 2 is 1. 180 over 2 is 90. Then 3 times 90 is 270 degree. So 3 pi over 2 is 270 degree. Now, What about if I want now to convert from degrees to radian? Here, I want to convert now from degrees to radian. I have a degree. I have now a degree. So, the degree multiplied by. Now, from degrees to radian. So, I need my answer in radian. So, up, I will write by. Down, I will write 180 degree. Then cancel degree. My answer will be in radian. As an example, if you have 210, I want the answer in radian. So multiply by over 180. 0 cancel 0. Then 18 divided by 3 is 6. Divided by 3 is 7. So it will be 7 by over 6. 7 by over 6. So here the answer of 210 is the same as 7 pi over 6. That's 210 in degrees and 7 pi over 6 in radian. Another example. All of you, please open your book, page 837, problem number 1. In problem number 1, they told you what is the degree measure of an angle negative 3 pi over 4 radians. So here I have negative 3 pi over 4 radians. This one is a radian, so I need this formula. Multiply by 180 over pi. Then pi cancel pi. Then 4 over 4 is 1. 180 over 4 is 45. Then negative 3 multiply by 45. 3 times 5 is 15, 12, 13. So negative 135 degree. So negative 3 pi over 4 is the same as negative 135 degree. Now, what is the radian measure of an angle? 27. If here we have now 27 degree, and I want to write it in radian, so I will use this formula. Multiply by over 180. Now, 27 over 3 is 9. 180 over 3 is 60. 60 over 3 is 20. And 9 over 3 is 3. So it will be 3 pi over 20. So 27 degree is 3 pi over 20. Now, we want now to fill this table. We want now to find sine and cosine of each angle in degrees or in radian. Now, here I give you the most common angles: 0, 30, 45, 60, 90, 180, 270, and 360. Now, here we have in degree, and here we have in radian. Now, 0 in a degree is the same as 0 in radian. Now, 30, I have a degree, and I want to convert it to radian, so pi over 180. Then 30 over 30 is 1. 180 over 30 is 6. So it is pi over 6. So 30 in radian is pi over 6. 45. Later, if you convert it using this formula, it will be pi over 4. 60, it will be pi over 3. 90, it will be pi over 2. 80 is pi. 360 is 2 pi. And 270 is 3 pi over 2. Now, if we have now this circle, with an x and y coordinate, now you have to know that here a semicircle, the measure of a semicircle is 100 is pi, or 180 degree. So the semicircle, it has a rotation which measures pi, and a full circle, it has a it rotates with a measure of 2 pi. So because of that, a semicircle has an angle of pi, and a full circle has an angle of 2 pi. Okay. Now, how can I find the sine and cosine of each angles? As we discussed before in lesson 2, if we have a unit circle with a radius of unit, so here we have 1, 1, 0. Here we have -1, 0. Here we have 0, 1. And here we have 0, -1. Here we have angle 0. Here we have pi over 2 or 90. Here we have pi. Here we have 3 pi over 2. And here we have 2 pi. Now, for angle 0, for an ordered pair, we told you before, x is a cosine and y is a sine. So 1, 0. So the cosine is 1 and the sine is 0. And the same as for 2 pi. 0 for the sine and 1 for the cosine. Now pi over 2. For pi over 2 here, the cosine is 0 and the sine is 1. For pi, the cosine is -1 and the sine is 0. Now for -3 pi over 2, as you see from here, the cosine is 0 and the sine is -1. So for 90 and 270, 90 and 270, these two angles, okay? Now, 90, it has a cosine, both of 90 and 270 has cosines of them are 0. And in 90, it has a +1, but 270 has a -1. The same for 0 and 180. They have 0 sines, and they have a 1 on cosine, -1 of cosine for 180. Now what about 30, 45, and 60? Now, you have to know that the angle of the sine 30 is 1 over 2, which is the same as cosine 60, which is also 1 over 2. Now, sine 60 is square root of 3 over 2, which is the same as cosine 30, which is also square root of 3 over 2. So now here we have, so the sine and is 1 over 2, which is the same as the cosine of 60, and cosine 30 is the same as sine 60. And for 45, the sine and cosine equal 45 is the same, which is square root of 2 over 2, and here also square root of 2 over 2. Now, in problem number 2, here they ask you to find the cosine and sine of a radian measure. How? If I told you that what is the exact value of cosine 7 pi over 6 and sine 7 pi over 6. Now to find the exact values of cosine and sine of any angle, I will use this circle and this table. If you have this circle now, okay, and if you have this circle now, okay, for this circle, I will draw its y and x coordinates. Now, 7 pi over 6. 7 pi over 6. Where is it? In which quadrant? So, to solve like this, you have to know that 7 pi over 6 is pi plus 7 pi. It is pi plus 6 pi over 6. So it is pi over 6 plus pi. So I will rotate from pi. Here I have pi. I rotate from pi with pi over 6. So here we have pi. I will rotate now with pi over 6. Starting from 0 with 7 pi over 6, or starting from pi with pi over 6 is the same. Okay, how can I find now the sine and cosine of 7 pi over 6? To find them now, after I know that it lies or it rotates after pi with pi over 6, so I will go now to pi over 6 here, which is 30. This 30, it has a sine and cosine values, so which is the same as 7 pi over 6. So cosine 7 pi over 6, which is the same as sine in pi over 6 because it rotates with pi over 6 from here, it's equal 1 over 2. And cosine 7 pi over 6 is square root of 3 over 2. It is the same as the cosine and sine for pi over 3, but pi over 6, sorry. But since this angle 7 pi over 6 is in quadrant number 3, and I told you before in quadrant 3, both the sine and cosine are negative. So because of that, here they are negative, and here also it is negative. So sine 7 pi over 6 is negative 1 over 2, and cosine 7 pi over 6 it's equal negative square root of 3 over 2. Without calculator, I can find the sine and cosine of any of these angles. Now, all of you open your book, page 840, exercise number 24. The measure theta of an angle is in standard position is given. Find the exact values of cosine and sine for each angle measure. I want you now to find the sine and cosine of 5 pi over 4. I have 5 pi over 4. Now, 5 pi over 4. 5 pi, it is pi plus 4 pi over 4. So it is pi over 4 plus 4 pi using the distributive property. 4 pi over 4, which is pi. So I am in pi here, and it rotates with pi over 4. So 5 pi over 4, it is an quadrant 3 with a rotation from pi with pi over 4. So now, to find the cosine and sine of each and of pi over 4 or of pi 5 pi over 4, I will use the cosine and sine of pi over 4. So going here now. For pi over 4, the sine of it is square root of 2 over 2, and the cosine of it is square root of 2 over 2. Now, the cosine, since I am in quadrant 3, and as we discussed before, both of sines and cosine are negative. So here it has a negative sign, here it has a negative sign. So cosine 5 pi over 4 is negative square root of 2 over 2, and sine 5 pi over 4 is negative square root of 2 over 2. Okay, it's number 22, 2 pi over 3. In number 22 now, here we have 2 pi over 3. They ask you now to find the cosine and sine of sine of 2 pi over 3. Now, 2 pi over 3, it is, here we have a 3, so it is 3 pi minus pi, which is pi minus pi over 3. So, what's the meaning of it? It means that here we have pi, it rotates with pi over 3 before pi, so it is here. Here is my angle. If I'm starting from 0, it is 2 pi over 3. And if I am starting from pi, before pi, which rotates with pi over 3. So because of that, if I need to find now the cosine and sine of pi over 3, I will use the cosine and sine of pi over 3. So cosine pi over 3 and sine 2 pi over 3. This is the same as cosine and sine of pi over 3. So sine pi over 3 is square root of 3 over 2, and sine of it is 1 over 2. Now, but I am in quadrant 2. And because I am in the quadrant 2, and as we said before also, in quadrant 2, the cosine is negative and the sine is positive. So the cosine here is negative and the sine here is positive. Okay, so this is a way to find an exact values of sine and cosine of any radian angle. I will use this circle with my given this given table to find any cosine and sine of any radian measure without using calculator. Now, in calculator, sometimes you find D and R. This D, it's means degree, and R, it's mean radians. So if you use R and you write sine of 7 pi over 6, it will give you the answer. And if you use it as a degree and you write it as 210, it will give you also the answer. Now, I'm finished now. I have finished our lesson today. Tomorrow, inshallah, we will discuss how can I find the length of an intercepted arc, and we will solve some problems relating to the converting radian to radian or radian to degree or degree to radian, and some of the problems like how can I write the exact values of cosine and sine of any radian degree.